Good morning, my dear students. Subject is basic electrical engineering. In last video, I started about the first model of DC circuits. Okay, again some basic concept of electric current as well as definition of electric current. Then electric current means the rate of flow of free electrons, or it is the flow of free electrons from one end to the another in a conductor, that is I is equal to Q by T. Okay, then SI unit is ampere it or coulomb per seconds. Okay, then it is represented by symbol I. Then another topic is electric circuits. Making one simple electric circuit using four parts, that is source, load, consumer and controller. Okay, source, load, consumer and controller, this becomes one simple electric circuits I discussed in last video. But your today's topic is types of electric circuits. Then there are different types of electric circuits are there depending on condition, then depending on current flowing as well as depending on circuit elements. There are different types of electric circuits are there. Then first one, depending on current flowing, there are two types, that is DC circuits as well as AC circuits. Okay, depending on current flowing, there are two types, DC circuits and AC circuits. DC means direct current circuits. Direct current circuit, here it is the current which always flow in one direction. The current will always flow in one direction. These type circuits are called as DC circuits. It is the current which always flow in one direction is called as direct current. These type circuits are called as DC circuits. Okay, it is also called as continuous or unidirectional current. DC means direct current circuits. Okay, in DC circuit, the magnitude of voltage or current remains same at any time, as shown in the diagram. This is one diagram for DC circuits. The magnitude of current or voltage remains same. It is same here at any time. Here 0 seconds, 1 second, 2 second, 3 second, it is constant. Okay, it is cannot change. Hence it is called as direct current circuits. Then DC circuits affects only resistance circuits. Okay, this is one type of electric circuits. Then second, AC. AC means alternating current. Here in an AC system, the voltage acting in the circuit changes polarity at regular intervals of time and resulting current changes directly. For example, this is one RLC circuit is there. The current will be flow here in R. Some voltage will be drop across in R. Some voltage drop across in L. Then some voltage drop across in C. Then current will be changed at regular intervals of time. Okay, means here 0, 1 second, 2 second, 3 second till reaches the maximum. It is called as amplitude. Okay, again reaches, it is giving one full positive half cycle. Again same, the current will be decreases then but it is in opposite direction. This is called as AC circuits. Okay, in the graph, the current increases from 0 to maximum value and decreases to 0 in one direction, and again increases from 0 to maximum and then decreases to 0 in opposite direction. Okay, in AC system affects only all circuit elements, that is resistance, inductance and capacitance. But in case of DC circuits affects only resistance, but in case of AC it affects resistance and inductance and capacitance. This is the main difference between AC circuits and DC circuits. Okay, next concept, circuit elements. Circuit elements means the resistance, inductance, capacitance, current source and voltage source, these are called as circuit elements. These are become one simple electric circuits. This is called as for definition of circuit elements, various components like EMF source, resistance, inductance and capacitance are connected in one circuit are called as circuit elements. Various components like EMF source, resistance, inductance and capacitance are connected in the circuit are called as circuit elements. There are two types of circuit elements are there, that is one active elements and passive elements. Okay, there are two types of circuit elements are there, active elements and passive elements. Now let us see one by one. Active, what do you mean by active elements? The elements which supplies the energy from the source are called as active elements. The elements which supplies the energy from the source are called as active elements. For example, voltage source and current source. This is the definition of active elements. Then passive elements. The elements which store the energy from the source are called as passive elements. The elements which supplies the energy from the source. You can store the energy from the source, okay, for some time. For example, resistance, capacitance and inductance. But in case of active elements, the elements which supplies the energy from the source, from the electricity, it supplies the energy, okay. But in case of passive element, you can store the energy for some time. For example, resistance, capacitance and inductance. Depending on using all circuit elements, again some electric circuits are again classified into two types, okay. That is one, based on the condition of circuit elements, electric circuits are classified into two types. That is one, passive element electric circuits. Then second one, active element circuit elements, okay. Depending on circuit elements, again there are two types of circuit elements are there. That is one, passive element circuit, then active element circuit, okay. Then third one, based on the condition of circuit, electric circuits are classified into three types. That is one, closed electric circuits, and second one, open electric circuits, third one, short electric circuits, okay. Depending on condition of the electric circuits, again there are three types: closed electric circuits, open electric circuits and short electric circuit. You can take one simple electric circuit diagram, it having the four parts. This is the electricity means source, controller means switch, lamp means consumer, then it is connecting wires means medium. This is one simple electric circuits. Here the current will flows from positive terminal to negative terminal. At time the controller means switch is in on position. You can switch on the supply, the current will flows from positive terminal to negative terminal. At time lamp is in on position. This is one simple electric circuit, okay. This is called as the closed electric circuits. In electric circuits, the current flows from positive terminal to negative terminal. The path become complete. This type circuits are called as closed circuit, okay. Then open circuit, as the name indicates, becomes open. You can take same example. This is one bulb, electricity, then it is connecting wires, one controller is there, okay. Whenever current will flows from positive terminal to negative terminal, the switch is in on position. The current will flow from positive terminal to negative terminal, but here the break in between load to source, the path become incomplete. Hence it is called as open electric circuits. In an electric circuit, there is a break or gap in between the wires. Circuit cannot complete the path. This type circuits are called as open electric circuits, okay. Then third one, short electric circuits. In an electric circuits, the line and neutral line directly touch each other. At that time, circuit becomes incomplete. Here you can see an example. This is one positive terminal, negative terminal, current will flow. This is one line wire, one neutral wire, directly touch each other, okay. This is also incomplete. Then current will pass, returns to the supply without passing the consuming load. This is the resistance is the consuming load. Such circuits are called as short electric circuits, okay. This is the types of electric circuits. There are three types mainly. Depending on current flowing, there are two types. That is one, DC circuits and AC circuits. Then depending on second one, depending on circuit elements, there are two types: passive circuit elements, active circuit elements. Third one, depending on condition of electric circuits, there are three types. That is one, closed electric circuits, open electric circuits and short electric circuits, okay. Now next concept, some electrical terms. That is electromotive force, okay. Next concept is some electrical terms. Electromotive force means EMF, okay. You can take another one simple electric circuits. Here current will move from positive terminal to negative terminal. The moving of free electrons, nothing but the current, the force is required. This force is called as EMF. Moving, the electromotive force is the force which circulates the electric current in an electric circuits. It is called as EMF. It is represented by symbol V and SI unit is volts. This is first one, EMF. Then second definition, electric potential. The capacity of a charged body. The capacity of a charged body to do a work is called as electric potential. The capacity of a charged body to do a work is called as electric potential. Therefore, electric potential is equal to work done divided by charge. Is equal to work means W, charge means Q. Then SI unit is volts. Then third one, electric potential difference. The potential difference between two charged body. Again, you can take this is one charged body, this is another. The potential difference between two charged bodies called as electric potential difference. The potential difference between two charged bodies called as electric potential. SI unit is volts. The first one is EMF, second one is electric potential, third one electric potential difference, generally called as PD. Okay, then fourth one, resistance. Resistance, material which opposes the flow of electric current. Any one material you can take. The material which opposes the flow of electric current in a circuit is called as resistance. Okay, then SI unit is ohm and represented by symbol R. Resistance means the material opposes the flow of free electrons or flow of electric current in an electric circuit is called as resistance. Then fifth one, conductor. Conductor means conducting means the flow of free electrons. The flow of free electrons. Then next definition, voltage. Voltage, it is represented by symbol V. The potential difference across the resistor. The potential difference across the resistor is called as voltage. You can take one simple resistors. The current will be flow here. The potential difference across the resistor is called as voltage. Then SI unit is volts. Next definition, node. Node. Okay, you can take any one electrical system. Node is very important. This is not a node. Okay. If more than two branches are meeting together one point, not two, this is not a node. Okay, this is if two branches are meeting together one point, it is not a node. More than two wires are meeting together, this is called as a node. Okay, any junction point in an electrical network where three or more currents are meeting together is called as a node. For example, this is one branch having R1 resistance, second branch R2 resistance, third branch R3. These are meeting together one point. This is called as a node A. Okay, this is one wire, second wire, three wires are meeting together one point. It is called as a node. Okay, this is called as a junction point. Node means any junction point in an electrical network where three or more currents meeting together is called as a node. Okay, this is seventh definition. Then next, branch. What do you mean by branch? Okay, branch means different path emerging from any node of an electrical network into which current divides are called as a branch. For example, here this is R1 branch, R2 branch, then R3 branch. This is I1 current will be dividing two branches like I3 and I2. This I1 current will be divides R2 and I2. This is the two branches. Totally there are three branches are there, but here this is I1 current will be dividing I1 and I2. I1 and I3. This is called as a branch. This is first branch, second branch, third branch. Okay. For making branch, the node is important. Where A is the node having three branches, R1, R2, then R3 are three branches. Okay. Definition of branch means different path emerging from any node of an electrical network. This is one electrical network of one. This is the A node. Current will be dividing like I2 and I3. This is called as the branch. Then last mesh. Mesh is a closed path or loop in an electrical network. This is one simple electrical network. This is one mesh, mesh 1, mesh 2. Mesh is the closed path. This is one closed path. Okay, this is another second closed path in which does not contain any other loop in it. Only the one loop is there. Inside this there is does not contain another loop here. This is mesh means this is the one closed path. This is A, B, E, D, A becomes one closed path. This is called as mesh 1. B, C, E, E, F, E. B, C, F, E, B. This is becomes second mesh. This is second closed path. Loop 1 and loop 2. This is called as mesh. Mesh means a mesh is the closed path or loop in an electrical network. Mesh is the closed path or loop in an electrical network. This is called as a mesh. Okay. Next definition, power. Power means the rate of doing work. The rate of doing work. Then SI unit is watts. The power means the rate of doing work. SI unit is watts. Therefore, power is equal to work done divided by time. In generally, work means force into displacement. In generally, work is equal to force into displacement. But accordingly in electrical, work means charge into voltage. If you can take here any one resistor, the current will move from this terminal to this terminal. The some amount of charge is there. Then work, it is moving of electric current from this end to this end. Then it is nothing but the charge, the voltage, it is nothing but voltage. The work force moving from current from this end to this is nothing but charge. Okay, this is voltage. This is voltage means displacement. Work is equal to charge into voltage. Therefore, work W is equal to charge means Q, voltage means V. Therefore, in electrical, work is equal to W is equal to Q into V. Therefore, electrical power is equal to work done divided by time. Work done means Q into V divided by T. Q into V. But Q means the charge. Therefore, I is equal to Q by T. Therefore, I is equal to Q by T. The rate of free electrons. Therefore, Q is equal to I into T. Now you can put the equation in electrical power. Therefore, Q is replaced as, you can put I into T. Then V as it is, T as it is. T will get cancelled. Then accordingly electrical power P is equal to V into I. P is equal to V into I. The electrical power, the rate of doing work, that is P is equal to V into I. It is measured in watts. Okay. Then last definition, energy. Energy is the capacity to do a work. Energy is the capacity to do a work. Then SI unit is watt second. Energy is the capacity to do a work. Then SI unit is watt second. Therefore, E is equal to V into I into T. V into I into T. Then it is measured in joules or kilowatt hour. Then SI unit is for larger quantity, it is measured in kilowatt hour. Then smaller quantity, watt second. Okay, this is about the basic introduction of DC circuits. Okay, next class I discussed about Ohm's law, then analysis of series parallel and series parallel electric circuits. Okay, thank you.